Hi, I'm Lois Just from University of Ljubljana and I'm excited to be here to share our work learning maritime obstacle detection from Weak Annotations by Scaffolding. To enable full autonomy in robotic boats, robust and efficient obstacle detection is essential for safe navigation and route planning. Obstacle detection in the visual spectrum remains a challenging task due to the highly dynamic nature of the water surface and large amounts of reflections and object mirroring in the water. Obstacles vary in appearance, but we can roughly divide them into two categories. First, we have static obstacles, which are mainly large static areas, like land or piers. Secondly, we have dynamic obstacles, which are mostly objects floating in the water. This includes boats, swimmers, debris, and so on. Currently, state-of-the-art methods use a semantic segmentation approach, as it can address different types of obstacles, both static and dynamic, in a uniform way. These methods produce water, sky, and obstacle segmentation maps, which are in turn used by the navigation systems of the boat for route planning. Unfortunately, semantic segmentation is a very general approach, and segmentation quality does not necessarily reflect the downstream detection performance. For example, similar site segmentation errors have very different implications for safe navigation of the boat. Missing a few details in the sky is not important for boat navigation at all, but false positive detections on reflections may cause frequent and unnecessary stops and slowdowns. Even worse, failing to detect an object at all is critical and might lead to collisions. Furthermore, annotating the dataset to create per-pixel ground truth labels requires significant effort and includes details irrelevant for detection. Instead, we propose to use detection-oriented annotations, or weak annotations for short, which requires far less labeling effort. Dynamic obstacles are annotated using bounding boxes, and static obstacles are annotated using a water edge line, which denotes the boundary between water and static obstacles. Such annotations are also used by recent obstacle detection benchmarks, and only contain the information relevant for obstacle detection. To harness these annotations, we propose the Scaffolded Learning Regime, or SLR for short. SLR is able to train full segmentation models using only the proposed weak annotations. It is compatible with most semantic segmentation architectures. SLR operates in three steps. In the first, warm-up step, we train the initial model using a combination of object-wise and background-wise training objectives. The initial model learns strong feature representations, but is overconfident in its predictions. We thus propose an introspection step that refines the model predictions using strong features and produces pseudo-labels. Finally, pseudo-labels are used to retrain the model with robust prediction capabilities. For additional details of SLR, please refer to the paper. We compare SLR trained models with traditionally trained semantic segmentation models. We apply SLR to DeepLab and Wasser, which is currently the state-of-the-art maritime semantic segmentation model, and we find large and consistent improvements for dynamic obstacle detection, with comparable segmentation performance for static obstacles. Detection improvements are especially large inside the danger zone of the boat, which is the most critical 15-meter large area around the boat. To summarize, we propose an alternative, detection-oriented way to train semantic segmentation models for obstacle detection using only weak annotations. This drastically reduces the required labeling effort while simultaneously improving the detection performance and achieves new state-of-the-art performance, which is a remarkable result. If you are interested in learning more, please refer to the paper and feel free to contact me. Thank you.